Good evening, viewers. My name is Agon Jeremiah Jason. So I am here to solve some problems and also to explain some problems to us. I would love that you follow up as we start. So we are going to have our board. 50 cm cube of carbon 2 oxide was exploded with 150 cm cube of air containing 20% of oxygen by volume. Which of the reactants was in excess? So we have 4 options on the board. So the first one, we have carbon 2 oxide, we have carbon 4 oxide, and we have oxygen, and also we have nitrogen. But let me tell you, ordinarily you have to know that nitrogen is out of the question or out of the option, as we are not having anything related to nitrogen in the question. So the first thing you have to do is to write out the equation from the question. We have carbon 2 oxide gaseous reacting with oxygen gaseous to give us carbon 4 oxide gaseous. So then the next thing we do is to balance the equation. So we know we're going to have this and this. And there is something you have to do again, that this question is particularly from gas laws. So which of the gas laws are we talking about? We're talking about the De-Luzer's law. And what does this state? It states that when gases combine, they do so in volume, which are in simple ratio to one another. That is, they are in simple ratio to one another. And to the volume of your product, that's what they're saying. So if you now look at the question now, it says that which of the reactants was in excess. So our target is the reactant part. Which one is more that is in excess? Is it the carbon 2 oxide or the oxygen? So that's our target. So what you have to do there is to quickly check some things. So we have the volume of CO used equals to 50 cm cube. The volume of O2 used equals to 20% of 150 cm cube of air. As we know that oxygen is not the only component of air, so that is, it is just 20% of the air that you have there. And what is the 20% of 150 cm cube? So that is 30. That is 30 cm cube. So from the mole ratio that we are having here, don't forget CO2 gaseous plus O2 gaseous to give us 2 molecules of CO2 gas. And if you look at the mole ratio, 2:1. So now the volume supposed to be 50 cm cube to 25 cm cube. But we are having 30 cm cube instead, which means that we've used more of the oxygen gas. But 25 cm cube of oxygen is needed, but 30 cm cube was used. Therefore, oxygen is used in excess. So our answer here is option C. So you have to take note of that. You must understand your gas law, especially your De-Luzer's law, so that you can answer this question perfectly. So that is that. So let's move to the question number 2. That is question number 2. We have 10 ml cube of distilled water used to wash 2.0 grams of a precipitate of silver chloride. If the solubility product of silver chloride is 2.0 times 10 raised to the power of minus 10 mole square per dm raised to the power of 6. what quantity of silver was lost in process. So we have 4 options as usual. So the first thing we have to do is to bring out to show the equation. The equation, that is the ionic equation. We have silver chloride solid. So it's going to be a reversible reaction. Plus chloride ion. So that is what we are having here. So the next thing we have to show is the solubility product of silver chloride, that is KSP, equals the solubility of silver chloride ion, aqueous, multiplied by the solubility of chloride ion, aqueous. So now that we've gotten that, we can also refer back to this, that this is in ratio 1 to 1 to 1. So which means that we come back to this part of the product side, we have since 1 mole of silver ion is equal to 1 mole of chloride ion. Therefore, we can say that our silver ion aqueous is equal to chloride ion aqueous, which means that any value we have for the solubility of this will also be the same value as this. So let's assume we have this as A. Definitely this one too is going to be A. So from what we are having there, don't forget we were told from the beginning that the KSP equals to what? 2.0 times 10 raised to the power of minus 10 mole square per dm raised to the power of 6. So from what we are having there, we can now say that KSP equals to, since this, the solubility of this. So we can now, since we say that this and this, they are the same, they are equal, that is, we can take them as A and A. So we can say that this is equal to A times A to replace this here. So which is also equal to this solubility product, that is 2.0 times 10 raised to the power of minus 10 mole square per dm raised to the power of 6. So which means that this one gives us A squared. And we need to know only A, which is going to be the solubility of silver ion. So we have this 2.0 times 10 raised to the power of minus 10 mole squared per dm raised to the power of minus 6. So to get our A now, we have to find the square root of both sides. 2.0 times 10 raised to the power of minus 10 mole square per dm raised to the power of 6. So square root will cancel square. So our A equals to the square root of 2 is 1.414 times, then the square root of this, that is half times 10, that will give us 5. That is 10 raised to the power of minus 5 mole per dm cubed. Since we are also dividing this one by 2 and also dividing this one too by 2, so we have this. So we should have, since our A is equal to this, therefore the solubility, yes, that is our solubility of Ag plus aqueous will be equal to 1.14 times 10 raised to the power of minus 5 mole per dm cubed, which is also what we meant by the quantity of silver that was lost in the process is known as the solubility. That is the solubility of the silver ion that we are having that equation to SS1 students. Okay, as we know that the universe is made up of matter, and matter is made up of atoms, and also the atom is made up of some subparticles like our proton, electron, and neutron. So, how do we have these to behave? These subparticles, how do they behave? So, Schrödinger equation explains more about the behavior of these subparticles in a particular system with respect to time. So, just like what we have here, Schrödinger equation is a mathematical expression which describes the change of a physical quantity. So this physical quantity we are talking about is talking about the wave function. And this wave function we are talking about includes the momentum of that particle, the time of that at which that we are having that particle, the position of that particle, and the spin of that particle. So over time, that is with respect to time, in which the quantum effects like the wave particle duality are significant. Just as we know that particles, the matter behaves as either wave or particle. That is why we have different scientists working on that. Just like we have the Broglie's equation that says that just focus on the aspect of the wave that it explains that matter behaves just like wave. But Schrödinger still move forward, explaining the duality. Talking about the two. And also we have the Einstein uncertainty principle that talks about the uncertainty of a particle, that you cannot decide the position and the momentum, that is the speed of a particular particle at a particular time. So if we move on, well, we have three major types of the Schrödinger equation. The first one is talking about the position space Schrödinger equation. The second one we have the time dependent. The third one we have the time independent. So the first one, we have the equation here where our I signifies a complex number. Our H signifies the Planck's constant, where our sigma here signifies the rate of change with respect to time down here, and our psi here is a Greek letter or Greek alphabet representing the wave function. The wave function, a function that assigns a complex number to a particle S, at a particular point S with respect to time. Where our M stands for the mass of that particle, our V stands for the potential of that environment of that particle. And also, if we move to the next one, the time independent, we will see that we have the similar things, these parameters there, but the H here stands for the Hamiltonian operator, while our E here stands for the energy of the system. To explain more about this, we always have to need time because it is a kind of complex topic. Thank you very much.